Today we're going to be running our receptor binding assay test kit. If you've ever run an ELISA, this is going to feel very familiar, but there are some key differences to pay attention to in the protocol. So when you order the kit, just make sure you follow the directions, you read them thoroughly, and you reach out if you have any questions. When you get your kit, it's going to look like this. We have a 10x assay buffer that you'll have to dilute. We have dried down synaptosomes receptors. These are really important to keep frozen at all times. So when we reconstitute them, we're going to immediately put it in ice to keep it cold. We'll have a dried down standard. It comes with a Brevetoxin standard. You can order a kit with a ciguatoxin standard, and the protocol again is a little bit different. But what we're going to do today is the Brevetoxin and a dried down fluorescent ligand that you'll also reconstitute. Also included is a filter plate and an assay plate. The assay plate is what we're going to use to mix up all the reactions and let them incubate. And we'll use the filter plate to extract out the extra liquid and unbound ligand so that we can measure how much toxin is in a sample. Okay, ready? Let's get started. The first thing we need to do is to prepare all of our reagents and standards. All right, so we will want to dilute our 10x assay buffer. To do this, we're going to add 90 mils of DI water, to 10 mils of our assay buffer. Buffer's good. Next, we'll want to resuspend our fluorescent ligand. To do this, we're going to add 60 microliters of ethanol, to the ligand and vortex to mix well. This is going to be a 100x solution that we will then dilute again later for the assay. We also want to resuspend our Brevetoxin ligand. We're going to add 35 microliters of ethanol, and vortex well to mix. You want to make sure that this is into solution. The next thing we have to do is to create a dilution series for our assay. I'm going to make a 1 to 10 dilution series today. Check out our data analysis video and you can see where sometimes you may want to make a 1 to 3 or a 1 to 5 depending on how you want to analyze your data. Today we're just going to do curves with a 1 to 10 dilution. So I'm going to add 10 microliters of each standard in a 1 to 10 dilution to 90 microliters of ethanol. So first thing I'm going to do is add ethanol, 90 microliters to every empty tube I have here. Then I'm going to add 10 microliters of our newly reconstituted standard 1. To the first tube. Pipette up and down to mix. Vortex to make sure it's nice and mixed. And repeat down the line. I'm not going to add any to the last one because I want this to be ethanol only. I'm going to label my standards so that I know standard 2, 3, 4, 5, 6, and this is just ethanol, so I'm going to label that with 0. I'm going to reconstitute the synaptosomes. Remember, these need to stay on ice and be reconstituted right before I'm starting my assay. So I'm going to go ahead and get ice ready. I'm going to put my plate in ice. So that everything stays cold, and now I'm ready to do my synaptosomes. These will go into solution fairly well, but you still want to mix them. Make sure every bit of the lyophilized receptor is in solution, and then put it on ice, ready to go. All right, so we're ready to get started. I've got my assay plate in the ice, nice and cooled. It's been there for a little bit. I usually like to use a sticky note to keep me on track because it can be a little difficult to see the wells and where you're pipetting when it's in the ice. And I follow a plate map as I go along. So I put the zeros on the edges with the main standard in the middle. Some plates and some plate readers, depending on your setup, can have edge effects where the edges are more variable than the inside part of the plate. It just depends on how your setup goes. So I usually put my most important stuff in the middle. If you check out our data analysis video, it goes over this a little bit more. So I'm going to start from low to high. And I try to put my pipette tip consistently, but all the way down into the bottom of the well, and I blow past the second stop just to make sure all of the standard is inside the well, and I haven't left any in the pipette tip. And so again, I follow 6 to 6, 5 to 5, and so on. Our highest standard is going to be what we reconstituted that came in the kit. And once you've loaded that, you've finished a set of columns. I always add the buffer after I loaded a set to make sure everything is washed down. So you'll add 195 microliters of buffer into the wells. This is your reconstituted buffer. And I make sure that that keeps everything into the wells before I move to the next column to load any samples that I have. Okay, I've loaded my whole plate with all of my standards and all of my samples that I want to test. I've put buffer, 195 microliters of buffer in the entire plate, and now I'm ready to add my synaptosomes. Again, I want to vortex, make sure it's nice and ready to go, nice and mixed. And I'm going to add 50 microliters of the synaptosomes to all the wells. Now we let it sit on ice for 30 minutes on a shaker table if you have it, with gentle mixing to bind. All right, so this has been incubating for 30 minutes, mixing the synaptosomes with the standards and the samples, and we're ready to add our fluorescent ligand. What you'll do is I have 5.5 mils of assay buffer in here, and we're going to add 55 microliters of our fluorescent ligand, which we reconstituted at the beginning, to dilute here into that. This is light sensitive, so we're going to want to cover this and work as quickly but still accurately as possible to keep this protected from the light, as much as you can. We're going to add 50 microliters of our diluted fluorescent ligand to all of our wells. I usually use my hand here just to track where I am so I don't get lost and miss pipette, add too much ligand to one set or too little to the next. All right, the fluorescent ligand is in all of our wells, and now all we have to do is add 200 microliters of our assay buffer to finish out all of our mixing wells for a total of 500 microliters. I'm going to cover this immediately. We're going to put it back on the shaker table for an hour to let binding reach equilibrium. So you're going to need a vacuum manifold or some kind of vacuum setup. This is the one we have for our plates, to be able to transfer the reactions onto the filter plate. Before you do that, you're going to want to pre-wet and pre-read the plate. If you watch our data analysis video, again, you'll see why. But to do this, we're going to rinse all of our wells with 250 microliters of our assay buffer. You want to get a good seal here, and then just pre-wet all the wells. Sometimes it can take a little bit for them to start going down. These are going down great. But if you find it difficult to pull a vacuum, you can help by just setting your gloved hand over it. A lot of times I will also, after pulling the vacuum, just kind of tap it out a little bit. You want it pre-wet but not soaking wet to read. You can see a little bit still on the napkin there. And then pre-read your plate. Okay, so our reactions have been incubating for an hour. Our reactions have reached binding equilibrium. They're ready to be transferred onto the filter plate so that we can remove all unbound ligand and read what's bound to the synaptosomes for measurements of toxins in our samples. So the first thing we're going to do is transfer our reactions from the assay plate into the filter plate while under vacuum. All right, the last thing we want to do is to rinse all of our wells with some assay buffer, just to remove any lingering unbound ligand. And you're all done. Ready to read on your plate reader. Just make sure that you've got a fluorescence plate reader capable of reading at the required wavelengths with a bandpass filter. So just check out our website for that information. Make sure your plate's really dry. Ready to go.